Yes, we hope that you was able to work the practice problem 1, find the mass of a half circular disc of radius 3 with density equal to 1 plus y squared plus x squared. Now we're going to be looking at a cylinder. So here we have a cylinder, and now we have added a what? A dz part to this, okay? And that's all it's going to be, dz. Extruding a circle in Z gives us a cylinder. Okay, so this is what it looks like. Let me take out, mold it from the outside. This is what we have. And the radius R. We have the change in R, dr, as we saw before. We see the angle, then we see the change in angle, d theta. We have our radius, which goes all the way around, which is a value of a. And now for the first time, we're able to see dz. Okay? So it's like a wall going up, as I can see it here. So remember that z is going to be equal to r dr d theta dz. Okay, take a little closer look at this. Okay, we have a cylindrical coordinate system. We have, remember, x equals r times cosine of theta. We mentioned y equals r times the sine of theta, and now we have z equals z. So that's why z equals dz. We have our volume here. Okay, remember, we have a volume, and it used to be dx, dy, dz, and now you see the dz stays the same, but the dx and the dy change. Now, for a ds, we have, in the rectangular coordinate, dx squared plus dy squared plus dz squared. So now, as we look at s, ds squared is equal to dr squared plus r times dr squared plus dz squared. So our area, this is what our area is equal to. So once we have the area, like we had before, on a 2-dimension, okay, then we can add a dz. Okay, now we want to add a dz to this. As you can see, we look at this again. We had our theta, then we had our d theta here, little change. We have our r, then we have our little change in r, dr. We have that here. Okay, as it's lifted up, that's where it is. And then we have our r, dr, which is this point here. Okay. We take another look at it, a little deeper look. They have lots of diagrams for this. Okay, we can look at it from this section. We have our r, and we have our dr, or the change in r. Then we have also here our change in z, dz. We have our change in what? theta. And here we have this area here. This line is r d theta. This line here is dr. And so when we have this formula, we have our volume, which is showing here, is our r dr, which is here. Then we have our d theta, which is here. We have our just our d theta, and then we have our dz. So if you multiply 1, 2, 3 sides, okay, length times width times height, we can get our dimensions. So let's do an example. Find the volume and moment of inertia of Z of a uniform cylinder of height h and radius a. Remember our formula for mass? This is the formula that we will be using. And this remembers our dV. We were told that we have a height of h from 0 to h. We have also a radius. Since it's a circle, it goes from 0 to 2 pi. And we have a radius of 0 to r. So we can break it down into this form. Our dz from 0 to h, our d theta from 0 to 2 pi, and our r from 0 to a. And what do we get? We get for the first, for dz, we get h, and because it goes to 0. And for theta, we get 2 pi, because the initial, our starting point is 0. And then we take the integration of r dr. So that gives us 1/2 r squared, and we put the a in at that limit, then we have 1/2 a squared. 2's to cancel, we get h pi a squared. Any questions? Okay, now we're going to go and look at the moment of inertia. So now, as we look here at the moment of inertia, remember, if it's z, it has to have x squared plus y squared, not z squared must be eliminated. Okay, times our dv. And so what we have here, we have our x squared plus y squared equals r squared, so we are substituting that in. And if we multiply this out, we get what? Another r, so that's r cubed. dr, we have d theta, and we have dz. D theta going from 0 to 2 pi, dz going from 0 to h as the height. And so, if we look at this here, we get h here, because the lower limit drops out. The lower limit on the d theta drops out, goes to 0. So we have 2 pi. We have h 2 pi so far. We take the integral of r3 dr, and if we take the integral of that, what we get is 1/2 h pi a to the 4th power. So we found both, and it didn't take much. Okay, so we're going to start another example, but we're going to stop part 2, and then we will start on part 3.